Where am I? What's this? This is the oldest rock in Scotland, and I'm going to tell you a story about Scotland through geological time with these rocks that are leading up to dynamic Earth. So, Glacial Gneiss, dated to be up to 3 billion years old, and is found in the Outer Hebrides up in the Isle of Lewis and Harris, and also found in the Northwest Highlands. This rock nearly melted at one point, right? It used to be a rock called granodiorite, and what's happened is it's been buried to depths of 50 kilometres and just about melted, and it's formed what's known as a gneiss, a metamorphic rock. Is that no class? You can find that in Scotland. Moving on to the next rock. Caledonian sandstone. Check that out, look at these grains, that's how you know it's a sandstone. How did the Caledonian sandstone form? It's actually quite interesting because it formed before there was fossils in our record. It formed before there was animals and fish and all that stuff. This has nothing in it, no fossils, just sediments that were deposited by rivers back in the day, braided rivers. And Scotland actually sat on a continent known as Laurentia. So these rocks are up to 1 billion years old, 1,100 million years old. You're finding them again in the Northwest Highland of Scotland. So next rock, come on, let's go.
By the way, we'll follow you, like, you're brilliant.
I love it, thank you so much. I'm just doing sun outside here. I love it. Cambrian period where I have a colliding continents. 545 to 443 million years ago, the Dalradian supergroup found in the Grampian Highlands between the Highland Boundary Fault and the Great Glen Fault. What's happened here? These used to be I need to start again.
No, just keep going.
These used to be sedimentary rocks, right? They were once upon a time deposited to the Iaptus Ocean, just off the coast of Laurentia. That's where Scotland was, part of this continent. Where are we? In here, known as Laurentia. You had this Iaptus Ocean in the middle, right? So what's happened? You've had the closure of the Iaptus Ocean. You've had Laurentia and Avalonia collide with each other. England was on Avalonia and Scotland was on Laurentia. And these two continents collided with each other 450 million years ago, forming these rocks, changing these rocks from sedimentary rocks into meta-sedimentary rocks known as the Dalradian supergroup today. Now that is shiny. That one's not as shiny, but you can get some really, really cool, interesting features in geology. Right, next. Greywacke, what we got? Some gentle squeezing of the rocks that are found in the southern uplands during the Ordovician period. We're here now. Again, these were formed when you had the closure of that Iaptus Ocean. Originally deposited as sediments, such as Greywacke. You can see at the side here, the layers of the different rocks. Now what happens is when you have a subduction zone, I need to put my can of Fanta down for this because I need to use my hands. The subduction zone that forms at this period of time, that subduction zone subducting under the continental crust, that's oceanic crust, that's old oceanic crust that formed like back in the day, right? It's old oceanic crust as part of the Iaptus Ocean. And as that's subducting under, it's denser, so it's going to subduct under and it's pulling a continent with it as well along the way. But as it subducts under, what do you think happens to all the sediment that was laid like on that oceanic floor? I nearly fell over. It gets squeezed into what's known as an accretionary prism at the end of that subduction zone, and sometimes you get the remnants of old oceanic crust pushed up and abducted into that subduction zone, into the continent from the subduction zone, and that's where you have your ophiolite, the Ballantrae ophiolite formation that forms down in the southern Highlands, right, near Girvan. Right, moving on to the next rock, what we got? Devonian period. Your old red sandstone. This represents the sediments that were deposited just after that mountain building sequence. Right? Your old red sandstones are formed across Scotland. And these are all the sediments that came from those mountains. Now this one in particular is actually Caithness flags, found up near Caithness in Scotland, but still represents a period in time. where you had old red sandstone formed, right? But this formed in a lake and has like the remnants of little wee fish bodies that you can find in it. If you're ever up in Caithness, go check it out. The old red sandstone was deposited by rivers, but a little bit by wind as well, but mainly by rivers, like then alluvial fans and from the mountains. It follows a story which is found mainly in the kind of Midland Valley, just south of that Highland boundary fault, but also in the north of Scotland too. But aye, old red sandstone, let's move on. Carboniferous. Got your different sequences of rocks here. Carboniferous period, what we got. Pretty cool. 290 to 350 million years ago, Scotland sat next to the equator. You had the deposition of all these sedimentary layers, right? So you had sandstones, siltstones, mudstones and coals. You had rivers that were carrying sands across these plains where you had like rainforests that existed back in the day. Because we were next to the equator, and during this point in time there was a glacial period of time, right? There was actually on Gondwana in the southern hemisphere a big ice cap that held up the carbon dioxide, which meant that there was more oxygen in the atmosphere, right? And because there was more oxygen, what does that mean? It means that everything's bigger. You had dragonflies flying about that were the size of your dog. Is that no mad? But anyway, you've got your limestones where you have your fossils, you've got sands, silts, muds, and they all compact over geological time. That's where your coals come from, and that's why we have Glasgow and Edinburgh in this area, because back during the Industrial Revolution, like whenever it was, we were mining the coal out. Without the Carboniferous period depositing all this coal in that, we wouldn't be here. We wouldn't be in this place at time. Well, that's your Carboniferous rock. Look at these wee baby fossils. Oh my god, I've never seen that before. That's got crinoid stems in it.
Oh my god.
Holy fuck.
Not crinoid stems.
No, that's crinoids. They're all crinoids. So I sat there, transgression and regression of seas. I'm going to need to wait, someone's in the next stone. Oh no, wait, they're gone now. Brilliant, let's go. Permian period. What happened during the Permian period? You had a supercontinent known as Pangaea. We've got our beautiful new red sandstone here, right? Look at that. The beds in it and everything.
Bad guy.
How does that form? Bad guy. That forms by the deposition of sediments that are carried by wind. They're red because they contain iron oxide. But these sediments that were carried by wind, you can see the cross-bedding that was formed, and that just represents the movement of the sediments through geological time. They all compact over time as well. And that is what it is like, your new red sandstone. We just need to wait a minute. New red sandstone. Scotland was here 290 to 206 million years ago. Aye, let's go, next rock. Oh, Jurassic limestone. You're not even looking at the bloody rock.
Cause.
Oh, you can actually see some bivalves in this. Look at that. I've never actually seen that before. Jurassic limestone, well, 206 to 65 million years ago. You had the Jurassic to Cretaceous period. Now there's only a certain area in Scotland where you can find these rocks, well except from in the North Sea, but on the Isle of Skye you find Jurassic, Triassic and Cretaceous rocks. Not many Cretaceous rocks. But what's really interesting about them on the Isle of Skye is you find footprints, dinosaur bones. There's remnants of old life from back in the day. Then what happened? You had a bloody asteroid hit the earth and kill just about all the dinosaurs, but it is what it is. And what we have 65 million years ago to 1.8 million years ago, you have your beautiful, what does that say, Paleogene to Neogene. Fucking hell. You had what's known as all the volcanism that's found in the west side of Scotland on the Isle of Skye, on the Isle of Mull. This is basaltic lava here, this big chunk of rock. You can see the amygdales that form in the basalt. Basaltic rocks formed at a certain setting at a mid-oceanic ridge, and back then, 65 million years ago, Scotland was situated at that mid-oceanic ridge where you had the continents moving away from each other. Similar to what's happening in Iceland today, you had fissures open up The lava wants to get to the surface, so it will make its way up. Sometimes it crystallises within the surface, and that's known as magma chambers or intrusions, such as the one that's seen behind me today, but that was actually formed during the Carboniferous period. We'll talk about that another time. That's the Salisbury Crag. But these basaltic lavas spewed out during a period of time where we had that opening, the first opening of the Atlantic Ocean. It's pretty cool and interesting. These amygdales form later on. They're known as vesicles to begin with. It's holes in the lava, like the magma. When it erupts at the surface, it's got gases in it and it forms all these little wee circles in it, which are known as vesicles. And they later fill up with different minerals, and then they're called amygdales. So this is actually known as amygdaloidal basalt. And that's probably quartz or quasio clays. Little wee baby geodes, aren't you? Look at how cute they are, they're so small. Oh my god, there's some that have eroded away from the rock. No, actually, that's just stones. Right, moving on. I think that's us. Quaternary period. I can't even fucking speak. What we got here? Glacial. This is a piece of the Dalradian supergroup by the looks of it. And what it's meant to show is actually like the glaciers scarring across it. It's known as striations here. Don't know if you can see it, but that's like what the glacier's done. It's just smoothed all these rocks out in the highland and caused these striations. That's what ice does. It cuts out everything that you see today. I don't know what the hell this thing is. It looks like desiccation cracks in the rocks. The past is the key to the future. I don't know who said that, but it's pretty cool. But these are desiccation cracks that form in mud. They've actually been filled with like some
Bonder.
No, there's like that's calcium carbonate because it's eroding away, not eroding away, it's like precipitating out.
What on earth?
Oh, I kept fitting here. Oh no, can I? Oh, that's sandstone.
Is it?
Yeah.
Oof.
Look at the mica. Well, it's probably in between a sandstone and a siltstone.
State you. That would have been good. That would have been some good footage. They're settled in there.
And that's our geological history of Scotland.